Hi. So what I want to do right now is I want to show you how to use this cool thing called the mole map. Now, what the mole map is showing you is how we can go from volume down to grams, okay, using the mole as the intermediate, or we can go from volume over to particles, atoms, or molecules using the mole once again. Now, if you're going to go from mole to volume, you're going to multiply by 22.4 because 1 mole of any gas at STP is equal to 22.4 or occupies 22.4 liters. Now, if you're in volume and you want to get out of volume and go to mole, you're going to make sure you divide by 22.4. Now, if you're in mass, okay, if you're in grams and you got to get to mole, we're going to divide it by the molar mass. Okay, and if we're in moles and we've got to get to grams, we have to multiply it by molar mass. So use these arrows here to help guide you on your journey through the mole map, etc. All right, so I'm going to leave this here and I'll keep coming back to it, but I'm going to try to show some examples. Now, this problem, okay, is I'm going to go from liters to grams. So once again, I'm up here in liters, and I'm going to go down to grams. So I'm going to go liters, moles, grams. Okay, so start off with what's given. I've got 11.2 liters, and what do I know? I know that 1 mole of any gas, regardless of what the gas is, will always equal or occupy 22.4 liters. So I'm going to go from liters down to moles, moles over to CO2, to grams of CO2, sorry. Okay, so I'm going to start, here we go. 11.2 liters of CO2. So step 1, go from liters to moles. So I'm going to take this liters and put it down here. What do I know? Oh, 22.4 liters are in 1 mole. So I come over here and I go 22.4 liters in 1 mole. So now what I've done is I've gone from volume down to moles. Now I'm going to go from moles to grams. This and this cancel, so now my answer is in moles. I'm going to go from moles to grams, just like I did earlier. So I'm going to put mole down here. And what do I know? I know that 1 mole of CO2 would occupy, well, let's add it up. Carbon is 12, oxygen is 16. So the total mass is going to be 44 grams of CO2 in 1 mole of CO2. Okay, so here we go. Let's do the math. I got 11.2 divided by 22.4. Well, that just magically happens to be 1 over 2. Now, I've got 2 over here and I've got 44 over there. So 44 divided by 2 is equal to 22 grams. So there's my answer. 22 grams of CO2 are present in 11.2 liters of CO2. All right, hope that was helpful. We'll go back here. Let me put this down. Let me get another example. Hopefully by now you realize I've had my baby. Me too. How many molecules are in 22 grams of CO2? So I'm down here, I'm in 22 grams, and I got to go to molecules over here. So I'm going to go from grams to moles down to molecules. Okay, so there's a couple things I'm going to need to know, and basically I'm just going to need to know the mass of 1 mole of CO2. So I take this and I bring it over here and I start off with that 22 grams of CO2. Draw a line, take whatever's here and put it down there. Grams of CO2. Okay, I don't take the numbers, I just take the units. So I got grams of CO2. Now what do I know about grams of CO2? If you get to a problem like this and you don't know what to do, look to your friend, the periodic table. And the periodic table is awesome. What it does is it tells you a number, it gets you out of this and connects you to moles. So I know that 44 grams of CO2 are in 1 mole of CO2. So if I do this and this, now I've got my answer in moles. So right now, I'm over here. Now what does my step say? If I'm going to go from here to here, I have to multiply it by Avogadro's number, 6 times 10 to the 23. So I'm going to take this and put it down there. Whoops. I know that 1 mole of CO2 will contain 6 times 10 to the 23 molecules. Of CO2. Okay, and there I am. Now let's do the math. 22 and 44, that's 1 over 2. 2 and 6 turns into 3. So my answer is 3 times 10 to the 23rd molecules of CO2. There we go. Ta-da! That's pretty awesome. Okay, so what I've done is I've showed you guys how to go from grams to moles, moles to volume, moles to molecules, or to go from molecules to moles to liters, okay, etc. Now, let's say I want to do this last step. I'll give you one more example. I'm going to go from molecules to liters. How many liters would, I don't know, 2.4 times 10 to the 20 molecules of CO2 occupy at STP. Now, you're wondering, what is this STP thing? This is standard temperature and pressure. So this whole thing that we talked about with volume of gas only works. So 1 mole of any gas would only occupy 22.4 liters at STP. If you change the pressure, it would probably occupy less than 22.4. If you increase the temperature, it would occupy more. So we want it at STP, so standard temperature and pressure. And this is at a temperature of 0 degrees Celsius and a pressure of 1 atmosphere. This is like at the ocean. Okay, now let's check it out. Start with what we're given. We're going to go from molecules, and we're going to go, so we're down here, and we're going to go up here and go over there. So I have to divide it by 6 times 10 to the 23, and then I'm going to multiply it by 22.4. Okay, so here we go. I'm going to go 2.4 times 10 to the 20 molecules of CO2. I'm going to take molecules of CO2 and put them down here. And what do I know about molecules of CO2? I know that there are 6 times 10 to the 23 molecules of CO2 in 1 mole of CO2. Okay? And then, so now I'm right here. I went from there to here. Now I'm going to go from moles to volume. Okay? So that means I have to multiply it by 22.4 liters. Take this unit, put it down there. Okay? So I'm going to write moles of CO2. And what do I know? I know that 1 mole of CO2 occupies 22.4 liters. Okay, so I'm going to cancel this with this, cancel this with this, and now I'm going to do my math. Well, I've got a 6 over here, and I got a 2.4. So what I can do is I can cancel the 2, I can move this 2.4 and make it a 24. Okay, if I make this number bigger, I have to make this number smaller. So now it's 19. Okay, so now I'm going to take 6 and 24, And what I'll get is 4. And now I'm going to take 4 times 22.4. Oops, come on, calculator. I'm going to go 4 times 22.4. Okay, and I'm going to get an 89.6. Okay, so this number times that number there, okay, times 10 to the 19 minus 23 power. So that 23 I'm going to subtract from that 19, okay? So when I do that, I get 89.6 times 10 to the negative 4. Now this, and that's liters. So now when I get here, this number, right, once again, has to be smaller than 10 and greater than 1. Well, it's way bigger than 10. So, but if I move the decimal over this way, if I make this number smaller, I must make this number bigger. So my answer is 8.96 times 10 to the, I made this number smaller, I have to make that number bigger. Well, what's bigger than negative 4? Negative 3 is bigger than negative 4. And there's my answer. Now, going back to it, that many molecules doesn't really occupy much. That's a small amount. That's like a tiny little bit. Okay? So, just letting you know, that's how we do it, and I hope that helped you. Have a good one.